Hello everyone, this is Chemical Reactions Made Simple with Miss Rodriguez, and today we're going over everything you need to know about the Chemical Reactions unit in high school chemistry. So today we'll be going over balancing chemical reactions as well as the different types of chemical reactions. But first off, how do you even know that a chemical reaction has occurred? You have to look for evidence of a chemical change. These are the things that you're looking out for. Was there a color change? Did it form a precipitate? Was a gas formed? Did the odor change or the temperature changed? In order for it to be a chemical reaction, something new had to be created. In order to balance chemical reactions, we need to figure out how many of each atom do we have. So in this compound, how many Mg's, P's, and O's? If we look at the subscripts, that tells us how many of that particular element there are in the compound. For example, the small 3 next to the Mg tells us that there are 3 magnesiums. However, when you have parentheses, you have to take the number on the outside of the parentheses and apply it to all of the elements inside the parentheses. So for example, P does not have a number next to it, meaning that there's only one phosphorus. But since we have to multiply that by 2 because of the 2 outside of the parentheses, there are 2 phosphoruses. There are 4 oxygens, but again, the 2 is also going to apply to the oxygen. So 4 times 2 gives us 8 oxygens. The coefficient, that's that big number at the front of the compound, tells us how many compounds we have. So for example, in this case, we have 2 of the Mg3PO42 compound. So each of the numbers that we got from the subscripts, we have to multiply by 2. So in total, there are 6 Mg's pictured, 4 P's, and 16 O's. The reason why we balance is because of the law of conservation of mass. According to this law, mass cannot be created or destroyed, only changed from one form to another. So what that means is whatever atoms you have in your reactants, we also have to see them in our products. So that's why we balance our equation to follow the law of conservation of mass. Here we see an unbalanced equation. On the left side of the arrow, we have our reactants. On the right side of the arrow, we have our products. Counting our atoms, there are 2 H's on the left and 2 H's on the right. There are 2 O's on the left, but only 1 O on the right. So currently, it does not satisfy the law of conservation of mass. This is how we balance our equation. You can only balance by changing coefficients. You cannot change the subscripts. If you change the subscripts, you change the compounds that you're working with. So looking at the H2 plus O2 makes H2O, the H's were already balanced, but the O's were not. We needed more O's on the right side. So we have to add another O. You can't just double the O, you have to double the whole compound. So let's go ahead and draw another H2O and let's recount our atoms. Now we have 4 H's total, so 2 plus 2, and we have 2 O's total, 1 plus 1. So 4 H's and 2 O's on the right. If we look on the left side, now our O's are balanced. There's 2 oxygens on both sides of the equation, but the H's have become unbalanced. So let's go ahead and draw another H2. So there was already one H2. We drew a second one. And now there are 4 H's on the left as well. So the H's are balanced and the O's are balanced. And now we can write our coefficients. In order to balance the equation, we needed 2 of our H2. We only need 1 of our O2. And we need 2 of the H2O. So by adding the coefficients, now our reaction is balanced. There are 4 types of chemical reactions. There's a synthesis reaction, decomposition reaction, combustion reaction, and replacement reactions. Synthesis reactions are when you combine two or more simple reactants to form a new, more complex product. For example, H2 plus O2 makes H2O. You have two reactants on the left, and they combine to form a singular product. Now, it doesn't always have to be two on the left, one on the right. As long as you end up with less products than you have reactants, then you have a synthesis reaction. Decomposition reactions are the exact opposite. They break a complex reactant into two or more simpler products. So if we flip the reaction we were looking at earlier, so here we have H2O and it decomposes into H2 plus O2. So we started with something more complex and we broke it down into two more simple products. And again, just like with synthesis, it doesn't have to be one reactant on the left and two products on the right, as long as you have more products than you had reactants. Then you have a decomposition reaction. Combustion reactions always involve oxygen as a reactant. It needs that oxygen in order to combust. And it's always going to make either CO2 or H2O. And in some cases, it's going to make both CO2 and H2O. So here we have the example of CH4 plus O2 makes CO2 plus H2O. So again, oxygen on the left, CO2 or H2O, or sometimes both, on the right. There are two types of replacement reactions. In a replacement reaction, the elements are going to switch places in order to form new compounds. The first type of replacement reaction is a single replacement reaction. So here we have Na plus HCl makes NaCl plus H2. So on the left side, we have Na, which is on its own, and H is bonded to Cl. But on the other side, the H is on its own, and the Cl is now bonded to Na. So the Na replaced the H. This is what makes it a single replacement. In a double replacement, both of the compounds are going to switch their partners. So for example, on the left side, Na is bonded to OH, and H is bonded to Cl. On the right side, Na is bonded with Cl, and the H that was with Cl is now bonded to the OH. So both of the compounds had to switch in order for it to be a double replacement. Replacement reactions can form precipitates. Precipitates are solids that form as a result of a chemical reaction, and they are insoluble. That's why they form, meaning they're not able to dissolve. For example, we have AgNO3 plus NaCl makes AgCl plus NaO3. So here we have another double replacement reaction. But notice that most of the compounds have AQ next to them, meaning that they are aqueous. They are able to dissolve. But AgCl has an S next to it, meaning that it's a solid. After the AgNO3 and the NaCl form their new compounds, the AgCl is no longer soluble, so it ends up forming a solid precipitate. If you look at the back of your periodic table, if you look at the solubility chart, which is at the back of the star periodic table, you'll see that you can actually identify if a compound is going to be a precipitate or not, so if it's going to be soluble. If you use the star reference material, if you look at the back of the periodic table, there is actually a solubility chart, which you can use to determine if compounds are going to be soluble or insoluble in water. So for example, HNO3, so we look for the NO3, and it's here under soluble, and there are no common exceptions. So HNO3 is going to be soluble. If we look for BES, so S is down here, insoluble, and if we look at the exceptions to that, BE is not on the exceptions list, meaning BES is going to be insoluble. LiOH, so now we're looking for OH. OH is insoluble, but if we look at the exceptions, alkali metals are exceptions. meaning when things are bonded to OH, it is normally insoluble, but since Li is an exception, LiOH is soluble. So it's an exception to the norm. If you know the type of reaction and you know your reactants, you can predict your products. For example, if our reactants are 2Mg plus O2, and we know that it's a synthesis reaction, meaning that they're going to combine to form a more complex product, then our product is most likely going to be MgO. And that's because Mg has 2 valence electrons, meaning it has a +2 charge, and O has 6 valence electrons, meaning it has a -2 charge. +2, -2 are already balanced into a net charge of 0. So MgO is already a balanced compound, meaning that it has no net charge. Now we have to make sure that the whole equation is balanced, meaning that it follows the law of conservation of mass. So whatever you have on the left, it has to show up on the right. There are 2 Mg's on the left, but only 1 on the right. There's 2 O's on the left, but only 1 on the right. How we make it balanced is by adding a coefficient of 2 in front of the MgO. So now we have 2 Mg's on the left and right. We have 2 O's on the left and right. So not only do we have a balanced compound, but we have a balanced chemical equation. For our second example, we have 2 NaCl plus F2, and we know that it's a single replacement reaction, meaning that the element that's by itself, so F, is going to replace one of the elements in our compounds. Now, which element is going to be determined by the charge? Na has a +1 charge, Cl has a -1 charge, and F, which has 7 valence electrons, just like Cl, is going to have a -1 charge. So it's going to replace the Cl, not the Na. So the compounds that are formed are going to be NaF, because again, Na has a +1 charge, F has a -1 charge, so that's already balanced, and Cl is going to be left on its own. Cl and F are both diatomic molecules, meaning that they're never on their own. There's always going to be 2 of them. So just like how it's F2, it's going to be Cl2. And we balance the rest of our atoms using our coefficients. There's 2 NAs on the left, but only 1 Na on the right. There's 2 Cl's on the left, and there's 2 Cl's on the right, so Cl is good. There's 2 F's on the left, but only 1 F on the right. So all we're missing to make this a balanced equation is a coefficient of 2 in front of NaF. So now we have balanced compounds and a balanced chemical equation. And that's how you predict your products. All right, that is everything you need to know about chemical reactions. Thank you so much for your time. Let me know if you have any questions in the comments below. If this video was helpful, make sure you hit that like button and subscribe so you don't miss any of my future chemistry content. If you would like access to this exact PowerPoint, it is on my TPT store called Chemistry Made Simple, as well as worksheets, labs, and activities that align with this unit, as well as all other units in high school chemistry. I hope you have a great day. Bye.